Hey students, so in today's lesson, I'm going to be going over exponential word problems involving growth and decay. So I want to start off with our equations that we use to solve exponential word problems. So they usually involve either a growth or a decay situation. And the difference between these two scenarios is whether it's increasing over time or whether it's decreasing over time. And you can notice that the two equations that we use are very similar to each other, except for one has a plus and one has a minus. So you first have to identify whether it's increasing or decreasing to figure out which one you're supposed to use. So our A value is the starting amount, our R is the growth or decay rate, and T is the time going by. So let's look at an example just to see how this equation is going to work. So in the year 2016, the estimated population of Canadian geese in a city was 750. The population is expected to grow at a rate of 12% each year. What is the Canadian geese population in 2022? Round the answer to the nearest whole number. Okay, so let's identify whether it's a growth or a decay situation. What keywords in this problem tell us which one it should be? Well, sometimes population problems have situations where they're decreasing, but in this case, it says it's growing at a rate of 12%. So that means we're going to use the growth equation that has the plus sign in the middle. So let's find all of our three values. A is the starting amount. So from the word problem, how much did we start with? We started with 750, so I'm going to plug that in for A. I'll just write that to start. And then next we have 1 plus our rate. So I'm just going to write the 1 plus so far. And then R is the growth or decay rate as a decimal specifically. So this is the growth rate. You can see the word rate there is 12%. However, we have to convert this percent to a decimal. And to do that, as a reminder, 12% has a little decimal point that we don't see after the last whole number. And you always move it over 2 places to convert a percent to a decimal. And so our new rate is going to be 0.12 or 0.12, if you will. I'll just write 0.12. That's a messy little decimal there, 0.12. And we're going to take this to the t power. So t is the time going by. How much time is going by? Well, I'll switch up my colors here to take a look at that. So it says they're starting in the year 2016 and they're ending in the year 2022. So just use regular subtraction to figure that out. 6 years are going to be going by, and so that's what we're going to plug in for our exponent there. So I'm up at my calculator website, desmos.com/scientific if you need one. And I just would encourage you to write the whole expression in the calculator. So 750 times 1 plus 0.12 to the 6th power. Remember, you can click this little button here to go to the 6th power, or you can do Shift 6, the caret option, and we get 1,480. Now you can't have, part of a goose decimal percentage or a decimal point. And so we're just going to round this to the nearest whole number. So that'd be 1,480 geese. So I want to go over some common mistakes that happen that you should ask yourself whether or not the answer makes sense. And considering we started with 750 geese and 6 years went by, that does sort of make sense that 1,480 geese would be the population now. So I want to go over some common mistakes. For example, if you accidentally use the decay function where it's got the subtraction sign in there, and you plugged in all your values, you would have got 348 geese. You could be like, oops, I accidentally used the wrong equation because the population should be increasing over time. Another common mistake that I see is sometimes people just forget to do the 1 plus or 1 minus in general. They just plug in the rate. And in which case, if you just plugged in 0.12, you would get a very, very small number. And that doesn't make any sense that it would be so small either. And so just go back and see where you may have made an error if that's the case. The last one is if you just forgot to convert your rate to a decimal. So if you just plugged in the number 12 without including a decimal point that was supposed to be moved over, you'd get, 2 billion geese, and that is way too ridiculously large for that to make sense. And so just kind of look at your answer and see if it makes sense in the end. Let's try another problem here. So Jacayla invested $5,000 into an account, earning 2% interest compounded annually. She made no other deposits and does not withdraw money. What is the balance of Jacayla's account after 8 years? So you may not be very familiar with banking terms, but I'll try to break this down as best as I can. So first of all, is this a growth or a decay problem? Well, if you are not very familiar with terms like interest or how banking works, they encourage people to put money in banks because you'll earn interest on it. The amount of money that you have in the bank account is going to grow by a small amount over time. So this is a growth problem. Now, let's find the other values. The starting amount for A, how much does she start with? She starts with $5,000. So we're going to write that down for A, and then do the 1 plus next. And then it says R is our growth rate written as a decimal. So what is that growth rate? I can see that the rate is 2%. Basically, the percentage is going to be your rate, but you have to convert it to a decimal. And 2% as a decimal is not 0.2. If you have the decimal point right here and you move it over 2 places, then you need a placeholder 0 there to have it written as a decimal correctly. So it's actually 0.02. And then we have t is our exponent, the time going by, and then t, it specifically says, is 8 years. So this is what we're going to type into our calculator. I went ahead and typed it in already, and we get this answer, and it's got quite a lot of decimals after it. But the question is, what should I round it to? Well, whenever you have a banking situation, you want to round it to however many cents there are, which is going to be 2 decimal places. So we're going to have $5,858, and we have 29 cents here, but this 6 is actually going to round it up to 30 cents. And so there we have that as our answer. And just be really careful with those rounding errors is kind of the biggest common mistake that I see. We'll do one last example here. Michael bought a car for $6,500 in 2018. The price of the car declines by 14.3% per year driven. How much will the car be worth in 2030? So first of all, what type of exponential problem is this? Is it a growth or is it a decay? And the key word here is declines. And so that means it's going to be a decay problem. So we're going to use the one with the subtraction symbol there. Okay, we'll start with A, the starting amount. Well, Michael's car is $6,500. That's our starting amount. We're going to do 1 minus this time. We need the rate written as a decimal. It is written with a decimal right now, but we need to convert this percentage so that it is from a percentage to a decimal. So 14.3 converted to a decimal, we're still going to move it 2 places over, is going to be 0.143, 0.143. And then t is how much time is going by from 2018 to 2030. That's going to be 12 years going by. So here we have $1,020.195068. Looking at the third decimal place over, this 5 is going to make it round up to 20 cents from 19 cents. And be sure to ask yourself, does this make sense in the end? If you start out with a $6,000 car, after 12 whole years, it does make sense that it wouldn't be worth nearly as much as it was originally. And there we have it for our exponential word problem practice.